Okay, we've now talked about infinite limits, and that's where we had a specific x value, like x equal to a, and the y values were approaching infinity, or the y value was approaching minus infinity. That was an infinite limit. Then we've talked about limits at infinity, and that's where we were talking about x values getting larger and larger, or smaller and smaller, and looking at what the y value is doing if it's approaching some fixed line. So those were our limits at infinity. So now we want to look at the two combined. What if we're looking at the limit at infinity and it's also going toward infinity? So these are called infinite limits at infinity, and the four situations you may have is you might be looking at a function f of x and look at x is getting larger and larger. So we're going to be looking at the x's going this way, and if the y values are approaching infinity, which would mean that the y values are getting larger and larger, then we would say the limit of f of x as x approaches infinity is equal to positive infinity. So here's x approaching infinity, and you can see there that the y is also approaching positive infinity. Now, we also could have the situation where as x is approaching positive infinity, the y value could be approaching negative infinity. So in that situation, we would have something like this. X is approaching positive infinity, the y is approaching negative infinity, so the function's graph would be going downward like that. Or we could have the limit of f of x as x is approaching negative infinity. So now we're looking at x values this way, and if the function's values are getting larger and larger, so maybe it's going like that, then we would say that that limit was positive infinity as x went to minus infinity. Or if the function's graph is x is going to minus infinity, so coming out this way, if the y values are approaching negative infinity, so the graph would look something like this. And in this graph that we have, displayed on the board here, this would have that the limit of the function as x went to positive infinity. So that's looking this way, what's happening to the y values. They're going toward positive infinity. And on this other side, we're now looking at the limit as x goes to negative infinity for the function, and the graph is going like this, so the y values are approaching negative infinity. So these are infinite limits at infinity. Okay, so the two types of functions I want to look at that'll have these infinite limits at infinity are the powers and then polynomials. Polynomials are just functions that are created by adding different powers of multiples of powers of x. So if you take n's a positive integer, 1, 2, 3, 4, 5, 6, 7, even starting at 0, all the powers of x can be written as x to a positive integer. Then you have some number in front of the x. Okay, so this polynomial is just made up of a sum of powers of x. Now, if we're looking at the limit of just a single power of x, x to the n, so x to the fifth, x to the third, x to the fourth, if x is approaching plus or minus infinity, it doesn't matter which one it is. If n is an even integer, so we've got an even power, that means that when we multiply that x by itself n times, if n is even, we know we're going to have a positive number. So it didn't matter whether x was approaching positive infinity or x was approaching negative infinity. Either case, this x to a power is going to be getting larger and larger as x is getting larger and larger, and it's going to be positive because the n is even. So this limit, when you have a big power of x, is always going to be positive infinity if the n is even. Now, if the n is odd, if you're looking at x approaching positive infinity, that means you're putting a big positive number into this x to the n. A big positive number raised to an nth power, it doesn't matter whether the n's even or odd, it's always going to be a big positive number. So we'd say that that limit was equal to positive infinity. If we're looking at x approaching negative infinity, now we're talking about big negative numbers, negative 100, negative 1,000, then that limit of x to the n, remember the x's are big negative numbers, if n is odd, then multiply x by itself an odd number of times, it's still going to be negative. It's getting bigger though because x is getting to be a larger number in magnitude, so we're going to have a negative infinity. And now look at it this way. If you're looking at 1 over x to the n, and x is getting close to infinity or minus infinity, now this is getting us ready for looking at rational functions. if x is getting closer to a positive infinity, then this denominator is getting larger and larger. So as long as n's a positive integer, then x times itself n times is getting to be larger and larger. So 1 over that's going to be getting closer and closer to 0. So writing it as 1 over x to the n where n's positive, or you can rewrite it this way where x is to a minus n power. Either case, if x gets larger and larger, that limit's going to go to 0. Okay, so now what this tells us is that if we're looking for a limit of a polynomial, so anything that's of this form up here where it's just sums of powers of x's with coefficients, what's dominating what this function is going to do for larger and larger x's is that very first term, the one that has the biggest exponent. So when you want the limit of a polynomial, all you have to do is look at the very first term. So this limit of p of x is going to be whatever the limit is of that first term. Just pay attention to the a sub n, x to the n. It doesn't matter if we're talking about positive or negative infinity here. So just drop all the extra terms, focus just on that first term, the one that's going to dominate, because you're multiplying the x times itself more times than any of the others. And that will tell you what the limit's going to be. Now, because the x is going toward either infinity or negative infinity, this x to an n is getting larger or it's getting smaller, depending on whether the x is negative or positive. Well, it's getting bigger, but it'll be a big negative number if the x is a negative infinity. But look at this, and you can memorize the rules here on 1, 2, and 3, but it's easier here if you just look at the specific numbers that you have and then determine, is this thing going toward infinity or minus infinity? If you have a polynomial, it's going to always go toward infinity or toward negative infinity on the two ends. So those are the only choices that you're going to have. Okay? So look at the individual numbers, what the n is and what that number is in the coefficient, and that'll help us to know what it's doing. So I'll show you some examples here. Look at these examples that I have drawn, though. This first graph is all x to the even power. So this is like x squared, x to the fourth. So here's y equal to x squared. We have y equal to x to the fourth. All the ones that have even powers look very similar to these. They just get a little more boxed off at the bottom, little square there. I said 4, I put 6. Those are all going to resemble that graph. Actually, I have the graphs. This is y equal x squared down here. This is y equal x to the fourth, and this is y equal x to the sixth. But they're all going to look pretty much the same. Always going to be all positive. Everything's above the x-axis, and as the x is getting larger and larger this way, the y's are always going toward infinity. And if x is going toward negative infinity, the y's are also going toward positive infinity. So in this case, the limits, when those powers are even, is always going to be equal to positive infinity. So that would be our case 1 up here. This other one shows different odd powers. So we have y equal x cubed, y equal x to the fifth, y equal x to the seventh, and so on. They're all going to resemble each other. You've got the part to the right of the origin, it's going to always be positive, and the part to the left is always going to be negative. So as x is going toward positive infinity, you can see the graph is going toward positive infinity, and if x is going toward negative infinity, the graph is going toward negative infinity, because you're raising the x, if it's negative, to an odd power, which is always still going to keep you with the negative value. Okay, so let's look at these limits. The first thing to recognize, if you want a limit, and it's a polynomial like this, now I'm going to look at x approaching infinity, and then I'm going to look at the limit as x approaches negative infinity. Now what you need to remember is that what's going to determine this limit is the dominant term, which is just that very leading coefficient, the one with the biggest exponent on the x. So this is going to be the same thing as the limit of just the 3x to the fourth. Okay, so now the next thing you want to do is look at what your x values are. in the first one here, we're looking at x approaching positive infinity. That means we're plugging in big positive numbers. So I'm going to use 100 for an example. If I put 100 in for the x here, raise it to the fourth power, it's going to be positive, times a 3, it's still going to be positive, and it's going to be a really big number. It's going to go toward positive infinity. Okay? In the second one, I'm looking at x's approaching negative infinity. So I know the x's in the second one here are going to be negative numbers. Okay? So now I'm going to put a big negative number, like negative 100, in for the x. When I multiply it by itself 4 times, it's going to now be a big positive number. Times the 3, it's still a big positive number, and that limit's going to be positive infinity. Okay? Now the second example. I want to look at the limit of the q, and because I recognize it's just a polynomial, powers of x, multiples of powers of x added together, they're all positive integer exponents. So I'm going to look at the limit as x approaches positive infinity. It's going to be whatever the limit of that leading term is, because that's the dominant term. It's going to determine what's happening on the ends. So now find the limit of this term. Now I'm looking at x approaching positive infinity. So my x's here are positive numbers. If I put a positive number in here for the x to the third, a positive number times itself 3 times will still be positive. So this part will be positive. Times a negative 3 is now going to be a big negative number. So this is going to be a negative infinity limit. And now let's look at the limit of the q of x. As x approaches negative infinity, that's going to again be determined by that leading term, which is minus 2x cubed. X is approaching a negative infinity. X is a big negative number. Put a big negative number into the x to the third. A negative times itself 3 times is going to be negative. Then times a negative 2 is going to be a positive number. We're going to have a big positive number for that limit. Okay? When you're looking at the behavior of polynomials as x goes to infinity or minus infinity, we sometimes call that the end behavior, and that's probably how you heard it back in college algebra.